So hello everyone. So in the previous lecture we have discussed about Bishop's conventional method, right, for the effective stress analysis, and we obtain an equation for the analysis like this. And so today we're going to discuss about the Bishop's routine or rigorous method. Right? So now the thing is, why we use this formula or this method, rigorous method, is that due to the errors that can occur when we conduct a conventional analysis. Right? Now the difference is this is the term rigorous means routine means it is a iterative method. That means it can check its own answer of the factor of safety and continue that process until a much degree of accuracy can be obtained. Right? So these errors when we do a conventional method may be up to 15%. So this can be reduced by conducting this rigorous or iterative method. So if you look at this is again the free body diagram, right? So you can see this is the equation that we obtain, right? So I'm going to say this is equation number one, and if we take the whole slices, that's why we have this sigma sign, right? Sigma sign. And if we take only one slice, so we know for one slice factor of safety is something like this: C dash L plus N minus UL tan phi dash divided by T, that is tan phi dash. And we know this N minus UL represent the effective stress, or N dash, right? Not the stress, actually the force, right? N dash. So therefore you can write this as C dash L plus N dash tan phi dash over T. That is the factor of safety. So what I'm going to do is I'm going to change these two elements F and T and write T as C dash L plus N dash tan phi dash divided by F, right? Divided by factor of safety. So here I have a new equation, right? So number 2. Right? So, and in the other hand, we can write that this N dash, as we know, this N dash is equal to N minus UL. So therefore we know this N dash is N minus UL. Therefore we know N is N dash plus UL. Right? So if we take again this free body diagram, the N and T and this W, we know this N and T are components of W, right? That we already know. So if we take the components, right, we can write the whole W, right? You know this is alpha. Then you can take the values of the angles, right? So this will be alpha and 90 minus alpha. So you can write W as N cos alpha plus T sin alpha. So what I'm going to do here is I'm going to replace this n, right, n, using this equation, right, using this equation. And so if I replace this, so n becomes n dash plus ul cos alpha, and also I'm going to replace this t using this, right, this equation number 2. So we can write C dash L plus n dash tan phi dash divided by f, that is t. This whole thing should be multiplied by sin alpha. So now we can separate this and get rid of these brackets, and we can write that I'm going to write n dash, you can see here n dash cos alpha plus ul cos alpha, and C dash L sin alpha divided by f plus n dash tan phi dash sin alpha divided by f. So we have that, and again I can rearrange this. I'm going to take L and n dash. This L, here we have this L and n dash separately. So I'm going to take L outside, u cos alpha plus C dash sin alpha f n dash cos alpha in this part, then E dash sin alpha. So this part should be divided by f, right? So what I am going to do is take this n, right, n dash, subject this n dash. So if I subject n dash, we know this part is w, right? So I'm going to subject n dash. So if I take n dash, that will be w minus L u cos alpha plus C dash sin alpha divided by f. This should be divided by cos alpha plus tan p dash sin alpha divided by f. Right. So we have an expression for n dash. So what we are going to do is take this n dash, right, and put that in the original equation, right? Equation number 1. So if we put that in equation number 1, so we will get a new factor of safety equation, f equals sigma we have the C dash L here, right? So the C dash L is there, then we replace this N dash by this whole thing. So plus minus UL cos alpha. I'm going to get rid of these brackets, right? UL cos alpha minus E dash L sin alpha divided by A, right? And this is divided by cos alpha and E dash sin alpha F, and this should be multiplied by tan E dash. So every of these things should be divided by at the end by the sigma t. So sigma t. So we have a new equation, right? So now you may think that now you may see a difference in this equation. What we have here is this f, we have a factor of safety value here and also here. So in both left hand side and right hand side there is a f value, right? So that's why I said that this is an iterative process, right? So what we are going to do exactly here is we first assume this value, right? What we do is we assume a value, let's say 2 or 1.5 at the start of the, as a starting point we assume a value 1.5, let's say, right? So we put that value and obtain a new factor of safety value. Let's say we got a different value now, right? So let's say we got 1.1, something like that. So the assumed value is 1.5, the output value is 1.1, right? So then what we could do is put this output value as the assumed value in the next step, right? So we continue this process until this output value is equal to the input value or the assumed value, right? So we can do this multiple times until this factor of safety of output value is equal to the assumed value, right? Or almost equal to the assumed value. So we'll see how we do this. So I have prepared an Excel sheet, and in your handout there are some changes you have to make, I think, right? So here it is the normal force is given as P, that is M, right? Same thing here, and it is given as a moment equation. So here I have reduced it as a force equation. So just put 1 here, and this x should be sin alpha, or this actually means W sin alpha means sigma t, right? So the other parts are the same, right? We know this sigma W sin alpha is sigma t, right? So that is some small modification you may have to make in your handout, right? But still this is again correct, but the difference is here it has considered the force equilibrium, not the force equilibrium but the moment equilibrium, right? That is the difference, right? So anyway, it is the same equation. So let's go back to the, let's say, the same scenario, same example, right, we conducted in the previous lecture, right? So in the previous lecture we had we created this Excel sheet, right, and found out that the factor of safety is something like this. So the factor of safety found out is 1.14, right? So 1.14. So what I'm going to do is, since we have already conducted this conventional analysis, I'm going to choose my assumed factor of safety value as 1.14, right? So this as 1.14 in our rigorous method, right? So let's see how our rigorous equation looks like in the spreadsheet, right? So I'm going to go to the second sheet, right? So here we have the equation, right? So I have carefully created different columns for each part, right? You can see this part is the same as the previous table, but this also, but an L, UL, C dash L. But this part you can see it represents this whole thing, right? So I have created Excel equation here, right? So it is simple now. I'm not going to write these things because now you already have some practice in the previous two lectures how we can compile an Excel sheet. Right? Only thing is little bit complex now, right? But if you can carefully compile this. Only need these parameters, right? So this part is represent in this step. Other than the f value, right? So why we have a non-value here is no value here, because I haven't decided the f value, right? Because f value I'm going to put in this cell, right? So you can see at the end $N6. So N6 is this cell, that is you can see so so I'm going to put my f value here. So this will be the same f value, right? So you can see I have given numbers, right? This T, this part W sin alpha, sigma W sin alpha, that is T, right? I have given a number 1, and C dash L number 2, right? And this part is number 3, and this part should be number 4, right? This is number 4. So you can see this whole part is 2 plus 3 over 4, 2 plus 3 over 4, that is here in this column, right? That is what represent by this column, right? 2 plus 3 over 4, 2 plus 3 over 4, right? Just take the cells and combine it like this. So finally what we have to do is, to find the factor of safety, we need to divide this one. So this is my number 5, right? So this 2 plus 3 over 4 is number 5. I'm going to divide this number 5 by 1. So this whole thing is number 5. Right? This will be your number 5, because sigma of whole thing, right? Sigma of whole thing, that's number 5, should be divided by number 1. Number 1 is sigma t, this one, right? So this should be divided by this, right? And these values I have obtained by taking these cells horizontally, because what we do is first calculate this part separately for each slice, then take the sum. So that means this whole thing we take the sum, that is this cell, right? Then we divide this cell by the sum of p values. So okay, so we don't need these sums actually. So I can put any value here, right? Any factor of safety value. This factor of safety 1.5, that is the assumed value. So we have output value here, right? So this is the output value. So I'm going to start with the value that we obtained in the conventional method. So let's say conventional method, we know in sheet 1 conventional method we obtain 1.14. So I'm going to take that value. So I'm going to put it as our input value or assumed factor of safety 1.14. So this assumed value is now 1.14. So the output value or this value is now, we put 1.14 and we got 1.37. Right? I'm going to keep only 2 decimal places, so 1.37. Right? So you can see there's a difference. So the input value is 1.14 or the assumed value, output value is 1.37. There is a difference, right? So the large difference is there. So therefore, in the next step, what we use is the output value as the assumed value. So now we are going to use this 1.37 as the assumed value, right? We obtain 1.37. We obtain 1.37, right, from this. Now we are going to put the assumed in the second step. This is the first step. In the second step, we use our assumed value as 1.37. Right? So in the next step, I'm going to put this as 1.37. So now we have a value 1.4. Right? So our output value now is, so this is the first step. So in the second step we have 1.4. But still you can see there is a difference, right? The input value is 1.37, output is 1.4. So our objective is to make this as same as possible, right? So in the next step I am going to put 1.4. So in the third assumed value or the input value is 1.4. Let's see what we have in the output. So we have 1.4 here. Now we have 1.41. Right? So it is much more closer. This is 1.41. So for one decimal place, it is almost the same. So next one, I'm going to put 0.41. Now we get the same value, right? So in the fourth step, we got the same value. In the fourth one, we use 1.41 in the input. So output we also got the 1.41. So if we get the same values in the two consecutive output values, we take it as the correct factor of safety, right? So you can see there's a difference, right? Large difference here. In the conventional method, we got 1.14, right? So here the factor of safety has been increased, right, due to this correction, right? This correction factor due to this iteration process. So that is the main advantage of this rigorous method, right? Although it is little bit complex, you can see the factor of safety is higher than we thought, right? So it can be helpful for the design purposes, especially, right, to be more economical. Likewise. So I hope you understood the process here. Now remember, this will not be a task in your exam, right? So this will not be given in for the exam, but maybe for the assignment, right? For the next assignment. So there's a software work also in the next lecture. So with that software work, maybe this will be given as a task in your assignment, but nothing of this like will be given in your final exam. Only up to the conventional method will be assessed in the exam, right? Okay, so we'll meet again in the next lecture, which is based on the software analysis, or use GeoStudio or SlopeW. Let's see how we analyze slopes using that software, GeoStudio or the SlopeW software package. Okay.